Imagine for a moment that all the water on Earth came from just one well. This isn't as crazy as it sounds. All water on Earth is connected, so there really is just one source of water, one global well, from which we all draw our water. Every ocean wave, every lake, stream, and underground river, every raindrop and snowflake, and every bit of ice and glaciers and polar ice caps is part of this global well. So whether you are turning on a faucet in North America, pulling water from a well in Kenya, or bathing in a river in India, it is all the same water. And because it is all connected, how we treat the water in the well will affect every species on the planet, including us, now and for years to come.
The water in the well. We live on a watery planet. Almost 70% of Earth's surface is covered with water. This surface water is found in oceans, lakes, rivers, streams, marshes, even in puddles and the morning dew. There is so much water that if you looked down at Earth from space, it would appear blue. But there is also water we can't see beneath the Earth's surface. This groundwater can be found just about everywhere. It fills the cracks in rocks and the spaces between rocks, grains of sand and soil. Most groundwater is close to the Earth's surface, but some is buried quite deep. Water is also frozen in glaciers and polar ice caps, and there is water in the atmosphere. Every one of these water sources feeds Earth's one well. Where is that water on Earth? Oceans have 97.23%. Ice caps and glaciers have 2.14%. Groundwater, 0.61%. Freshwater lakes, 0.009%. Inland saltwater seas, 0.008%. Moisture in the soil, 0.005%. Water in the atmosphere, 0.0001%. And rivers, 0.0001%. Yes, there is more water in the atmosphere and soil than in all of Earth's rivers.
Recycling water in the well. The water you drank today may have rained down on the Amazon rainforest 5 years ago. 100 years ago, it may have been steam escaping a teapot in India. 10,000 years ago, it may have flowed in an underground river. 100,000 years ago, it may have been frozen solid in a glacier. And 100 million years ago, it may have quenched the thirst of a dinosaur. The amount of water on Earth does not change. There's no more water now than when the dinosaurs walked the Earth. The same water just keeps going through a cycle over and over again. This constant movement of water is called the water cycle. During the water cycle, water evaporates from oceans, lakes, rivers, ponds, and puddles, even from plants and animals. It rises into the air as water vapor. As water vapor rises, it cools into tiny water droplets. This is called condensation. These droplets form clouds. Gradually, clouds collect more and more water droplets. The average white cloud weighs about twice as much as a blue whale. When water droplets get too heavy, they fall from clouds in the form of hail, snow, or rain. This precipitation returns to the oceans, lakes, and rivers. It also seeps into the soil and down into the groundwater. Year after year, water continuously circulates through the water cycle.
Plants at the well. The first plants on Earth began life in the water about 450 million years ago. Some were washed ashore. At first, they could live only in wet areas. Gradually, they developed root systems that allowed them to tap into water in the soil. Water is essential to plants. In fact, plants are mostly water. It's the water in their cells that gives them their shape and their form. Without it, they droop and shrivel. Water also helps plants make food for themselves. Plants use the sun's energy to change water and carbon dioxide into simple sugars that feed the plant. This process is called photosynthesis. Water then helps carry this food throughout the plant. During photosynthesis, plants also release water vapor into the air. Roots absorb water, which is carried to the stem. The stem acts like a water pipe in your house, moving water through the plant to the leaves. From the leaves, water is released back into the atmosphere. This is called transpiration. The water that is transpired is added to the cycle of water on Earth. Water is important to plants, but plants are also important to water. Plants' roots anchor soil and stop it from blowing and washing into lakes and rivers. Leaves and branches trap rainwater, allowing it to seep slowly into the soil instead of flowing quickly away. And trees provide shade, which helps keep moisture in the soil. Plants depend on water from the well for survival, and the well depends on plants to help move water through its cycle. Without plants, the water cycle would be disrupted. Without water, plants could not survive.
Animals at the well. Like plants, animals, including you, are mostly made of water. The water in animals is very important. It carries nutrients, helps digestion, removes waste, controls temperatures, cleans eyes, and lubricates oils, joints. Water habitats are also home to many of Earth's animals and are where many animals find their food. Watery species such as fish, crabs, shrimp, and zooplankton are an important part of food chains around the world. The food chain is a link that connects animals and other species based on who eats whom. Without water-based species, food chains and food webs, collections of food chains, would collapse. Animals would starve. Animals not only need water to survive, they are also part of the water cycle. Animals add water to the atmosphere by breathing, sweating, peeing, and even drooling. The water you brush your teeth with today may have been the spray of a beluga whale 10 years ago. Some of the wettest animals on Earth are the jellyfish. They are about 95% water. Frogs and earthworms are about 80% water, while dogs, elephants, and humans are about 70% water. All animals need water to drink, even desert animals. They get much of the water they need from the food they eat. Animal life began in the ocean. Then, about 360 million years ago, some animals started to evolve. Their bodies began to change and they slowly adapted to living on land.
Watery habitat. A habitat is a place where animals can find everything they need to live: food, shelter, space, and water. Water is such an important part of an animal's habitat that if there isn't enough available, an animal will move away, even if all other needs are met. Most animals depend entirely on watery places such as oceans, lakes, and wetlands for their habitat. Freshwater habitats, lakes, rivers, streams, are home to about 12% of all animal species in the world. Saltwater habitats, oceans, seas, and some saltwater lakes are home to 60% of all fish species, as well as many other species, including mammals and reptiles, such as whales, turtles, and sea snakes. Some of these animals live their whole lives in water and wouldn't survive out of it. Others, such as frogs, toads, and many insects, spend part of their lives in the water and part on land. Whether water is their habitat or just part of their habitat, animals could not survive without it.
People at the well. Since the beginning of time, people have depended on water for drinking, for food, for bathing, and for watering their crops. Water has always provided a highway to move people and products from place to place. As cities and societies grow, so does their need for water. Today, water is essential in our homes, in industry, and in agriculture. At home, we use water for cleaning, cooking, drinking, flushing toilets, and for bathing. But homes account for only 10% of all the fresh water used. About 21% of the water we use goes to make everything from computers to cars. Water is used in hydroelectric plants to generate electricity and in petroleum plants to make gas. In factories, water is used to heat things up or cool things down and to wash away waste. Water vapor, steam, even runs machinery. Water is also an ingredient in many products, such as lotions, shampoos, chemicals, and drinks. And the remaining 69% of the fresh water we use goes into agriculture. Farms use huge amounts of water for crops and livestock. Look around. Almost everything you see was made using water. It took about 130 liters, or 34 US gallons, of water to make your bike. Water was used to grow and make the food you eat and the clothes you wear. Water was even used to make the paper for this book and the ink used to print the words. It takes about 185 liters, 49 US gallons of water to produce just one glass of milk. This includes the water the cow drinks, the water used to grow food for the cow, and the water needed to process the milk. About 147,000 liters, 38,800 US gallons of water was needed to make your family's car. A lot of water is required to produce the food you eat. Approximately 5,200 liters, or 1,375 US gallons, of water is needed just to make one fast food lunch, burger, fries, and a soda. In North American homes, the bathroom is where about 3/4 of all water is used. One flush of the toilet regularly uses nearly 13 liters, or 3.5 US gallons. Nearly 1 billion people around the world depend on fish as their primary source of protein. Thirsty? People drink on an average of 2.5 liters, or 2/3 US gallons of water a day. In your lifetime, you will drink the equivalent of a backyard swimming pool full of water.
Fresh water in the well. Though we live on a watery planet, not all the water can be used to meet our needs. That's because we humans and many other species depends on fresh water, and supplies of fresh water are limited. Most of the water on Earth is salt water, almost 97%. Only 3% is fresh water. If a tanker truck filled with water represents all the water on Earth, then the water used to fill a large bathtub would represent all of the planet's fresh water. But most of the fresh water, over 99%, is frozen in ice caps and glaciers trapped deep underground or in the atmosphere, so we can't use it. How much fresh water is available to us? Remember that bathtub? Imagine filling 9 pop cans from it. This represents all the fresh water we can use. While there is a lot of water on the planet, we have access to less than 1% of it. Lake Baikal in southeast Siberia contains almost 1/5 of all the fresh water on Earth. It's also home to the Baikal seal, one of the world's few freshwater seals. Approximately 0.001% of all water on Earth is in the atmosphere. If a tanker truck represents all the water on Earth, the water in the atmosphere would barely fill a third of a pop can. The Bering Glacier in Alaska is the largest glacier in North America. It's about 5 times bigger than New York City and nearly twice as tall as the Empire State Building. Around the world, more than half of the drinking water we use comes from underground aquifers, layers of gravel, porous rock, or soil that traps large amounts of water.
Access to the well. Some families are lucky. They can turn on the tap for drinking water, to fill a bathtub, to wash their car, or water the garden. But other families around the world are less fortunate. 1 billion people, almost 16% of Earth's population, have to walk more than 15 minutes to get to the nearest water supply. There, they gather water for the day, just a few jugs, barely enough for drinking, cooking, and cleaning. Other families don't have access to enough water to meet even those basic needs. While the amount of water on Earth is always the same, the distribution of water across the world isn't. Huge differences in rainfall can happen from country to country and even within the same country. Less rainfall means less water available in lakes, rivers, and aquifers. Sometimes there just isn't enough water where it's needed most, because water is not evenly distributed around the globe. Nearly 1/5 of the world's population does not have access to enough water. Many of these people live in Africa and Asia. A bucket of water weighs about 10 kilograms or 22 pounds. Imagine if you had to carry a bucket or 2 from a well to your house every day. North America has 1/3 the population of Africa, yet North Americans use 3 times as much water. How is this possible? Nearly 300 million people in Africa do not have access to enough fresh water. China and India are home to over 1/3 of the world's population, yet they only have access to 1/10 of the world's fresh water. And here is the average daily water use per person in a wonderful bucket table illustration. In North America, the average daily use per person is 55 buckets. In Russia, the average daily use of water per person is 27 and a half buckets. In Poland, it's 14 buckets. In India, 7 buckets. In Nepal, 3 buckets. In Haiti, 1.5 buckets. And in Ethiopia, only 1 bucket.
Demands on the well: 7,324,782,000, give or take a few. That's how many people there are on Earth, and that number is growing every day. More people mean a greater demand for water. But this growing population isn't the only thing putting a strain on our water supplies. The average person today uses about 6 times more water than 100 years ago. A growing population also means we need more space. As towns and cities grow to accommodate all these people, they gobble up land, which also affects nearby water. Houses, buildings, and roads sometimes take the place of wetland habitats where animals live, which puts species at risk. They also change the way rainwater, lakes, and streams flow. And pavement and concrete block rainwater from refilling underground water supplies. There are more of us, and our demand for water at home, in industry, and in agriculture has grown tremendously. But all the water we have is all the water we ever will have. There is no more water now than there was 100 or 1,000 or even 10,000 years ago. And there will be no more 100 years from now, when the population may be closer to 10 billion. We need to find a balance between our demands for water and the amount of water that's available to us.
Pollution in the well. The water cycle helps keep Earth's water clean. As water evaporates, minerals, chemicals, and dirt are left behind. The water vapor that rises into the atmosphere is relatively clean. When rain falls back to Earth, some of it is filtered through rocks and sand as it further cleaned. Even plants play a role. As water travels through them, plants remove chemicals in the water. Then they transpire clean water back into the air. But more and more waste from our industry, agriculture, and homes is getting into the water. Runoffs from backyards, cities, and farms dump dirt and chemicals into lakes, rivers, streams, and ponds. Pollution in the atmosphere from cars and factories mix with water vapor in the air. The rain that falls pollutes surface water and groundwater. Our actions may be overloading water's natural ability to clean itself. As more water becomes polluted, there is less clean water available. Nearly 80% of all sicknesses in the world are caused by unsafe water. And wildlife suffers too. Water pollutants threaten the health of many species and habitats across the planet. Because of water's self-cleaning powers, the effects of pollution can be stopped and quite possibly reversed. But to do so, we need to reduce the amount of pollutants that get into our water.
Saving the water in the well. Water has the power to change everything. A single splash can sprout a seed, quench a thirst, provide a habitat, generate energy, and sustain life. It also has the power to unite or divide the world. Water is the most basic and important need of all life on Earth. But Earth's one well is in trouble. There is simply not enough clean water to go around. Taking actions to conserve water can help save the well. Conserving water means protecting both the quantity and quality of water on Earth. For example, using less water helps prevent water sources from drying up, and reducing water pollution protects the overall health of the well. Water conservation can help ensure there is enough clean water for everyone on the planet. By becoming more aware of how you use water and by using less, you too can protect the water in Earth's one well. Remember, every drop counts. Becoming well aware. Water conservation isn't just something for governments, corporations, and environmental groups to think about. Everyone needs to get involved in water conservation, even you. And it's not hard to do. It doesn't even mean living without water, it just means becoming well aware of every splash of water we use. By reducing your water use, you too can become well aware. Even the simplest actions can make a huge difference. Imagine all the water you could save just by keeping drinking water in the fridge instead of letting the tap run to get cool water. And by making sure to turn off faucets so that they don't drip, you can save up to 10,000 liters, 2,650 US gallons of water a year. But becoming well aware doesn't just mean using less water. It also means taking better care of the water we have. You can protect water from pollution by walking more and driving less, which keeps car exhaust from polluting water in the atmosphere. Organizing shoreline cleanups keeps trash from entering lakes, rivers, and streams. Planting trees anchors the soil so that it doesn't wash into waterways and make them muddy. Imagine what would happen if each of us did just one thing to conserve water and protect Earth's one well. These actions would add up. Together, they would help to ensure that there is enough clean water now and for years to come. Here are just a few ways you can become well aware. Learn more and educate others. By learning more about Earth's one well, you can make choices in your life that help conserve and protect water. Then share what you learn. Help the people around you become well aware too. Join others. There are many organizations working to protect water or helping people get the water they need. Find out more about organizations that interest you and support their work by raising money, volunteering your time, or helping to spread their message, or start your own campaign. Conserve water. With your family, explore all the ways you use water and then brainstorm ways to reduce your water use at home. Some suggestions include turning off the water while scrubbing your hands and brushing your teeth, running the dishwasher and washing machine only when full, asking your parents to fix leaky faucets, collecting rainwater to water the plants in your garden or house, watering your lawn only when it needs it and only in the early morning or evening, when less water will evaporate. Protect water. Rainwater can wash waste and pollution into storm sewers, which flow into local rivers or lakes. Oil, grease, salt from roads, fertilizers, and pesticides from gardens, paint, oil, leaves, and litter can all end up in local waterways. Many communities paint fish or other symbols near sewers to remind people that sewers empty into waterways. Does your community have such a program? If not, why not try to start one? Improving access one well at a time. More and more children and their families are becoming well aware. Some, like Ryan Hurljack, are helping to make water more accessible to those who need it most. In 1998, as a 6-year-old, Ryan learned that many people in Africa didn't have access to clean water. He raised enough money to build a well near a school in Uganda. But he didn't stop there. With his parents' help, he started the Ryan's Well Foundation, which continues to raise money to build wells in Africa and educate people elsewhere about the need to conserve water.